All right, so now we're back. Now we're going to talk about the greatest common divisor. So we've seen what is the divisor. Now, what is the greatest common divisor? Well, if we let a and b be natural numbers, then the common divisors of a and b are those natural numbers that divide both a and b. Now, the greatest common divisor is the largest of these common divisors, okay? And so what does that mean? Well, let's look at an example or two here. And so it says find the greatest common divisor of 12 and 18. So let's look here. We have 12, and we have 18. And so we have to find all the divisors, basically all the numbers that we can divide into 12 and give us a remainder of 0. All right, so what about this? Well, 12, we can divide that by 1, and we get a remainder of 0 because 1 will go into 12 12 times. 2, 2 will go into 12, and we have a remainder of 0 because 2 times 6 is 12, so 2 is a divisor. What about 3? Well, 3 times 4 is 12, so that works as well. What about 4? Well, 4 we already said was 3 times 4. And then 5, well, if you take that 5, we have a remainder of 2. So that's not a divisor. But 6 is a divisor because 6 into there would be 2 with a remainder of 0. 7, nope, that doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11 doesn't work. 12 works. And so 12 will go into there once and a remainder of 0. And so those are all the common divisors. And all we did was we took basically 12 and we divided it by 1. We started at the lowest and then we divided by 1 and we got 12 and then a remainder of 0. Then we divided it by 2 and we got 6 with a remainder of 0. And we just went through all of them and we got our list of divisors. Now, it takes a long time, as you can tell, to find a list. Think if we have now 35 and 42, those might be even longer lists than this one. And 18 should be longer than this one because it's going to have more numbers we can divide. So 18 divided by 1 works. We can divide by 2 and we get 9 with a remainder of 0. 3 times 6 is 18, so 3 will work. Now 4 doesn't work. 5 doesn't work because we have a remainder. 6 times 3 is 18, so that'll work. 7 doesn't work. 8 doesn't work. 9 works because 9 goes in there twice with a remainder of 0. 10, no. 11, no. And if we keep going all through all of them, what we're going to find is every time we multiply here, we have a divisor, 3 and 6, 2 and 9. And so that means 1 and 18. So that's kind of another way to look at it because, when we did the 1 and 12, those were both divisors. We did the 2 and 6, those were both divisors. And then if we did the 3, it was 3 and 4 were both divisors. And so the same thing works with the 18. We just have to do all the divisions and find the remainder of 0, and then both of those will be a divisor. Okay, so now the greatest common divisor. So what's the biggest number in common between them? Well, not 18, not 9, but 6 is our greatest common divisor. So the GCD is going to be 6. All right, so let's do the same thing now for 35 and 42. All right. Well, we can take 1 times 35 and get 35. So 1 is, and we also know 35 will be. Well, 5 being here, it's not going to be divisible by 2. It's not going to be divisible by 3. It's not going to be divisible by 4. Divisible by 5? Yes. So 5 will work. 5 goes into 35 7 times. So we know 7 is also going to be a divisor because it's one of the factors to get 35. Now 6 doesn't work because 6 times 6 is 36 and 6 times 5 is 30. So 6 doesn't work. And then we notice now we have to go all the way to 35 before any other divisors actually work. And that was when we took 1 times 35. Then we have 5 times 35. So those are the only divisors of 35. Now about what 42? Now that one's going to have more because we have an even number. So 1 will work, 2 will work. Now will 3 work? Yeah, 3, if we take that in there, 3 goes in here once, that's 3, subtract, that's 1, bring down our 2, that goes in 4. So we'll have a 3, and notice we'll have also a 14. So we had a 2 was in 42, that's 21. So we're going to have a 21 and a 14 we can write down here later. All right, so how about 4? Well, no, 4 won't work because it's not going to be even. 5 won't work. 6, yeah, 6 will work because 6 goes into 42 7 times, and that gives us 42 with a remainder of 0. So 7 is also going to be 1. Okay, well, 7 is going to be 1. That's good. Now we've reached that point where we start matching with previous things. So 7 worked with 6, 3 went with 14, 2 went with 21, and 1 went with 42. And so that is all of our divisors. Now, which one's the greatest? Well, we look here and we have 1, and then after that, it looks like 7 is going to be the greatest common divisor. Okay. And so that's how we go about looking through it. It takes a while because you have to go through all the different things, but then we'll actually find our greatest common divisor. Now, what are we going to do with the greatest common divisor? Well, we're going to use it to help us reduce fractions to lowest terms. All right, what does lowest terms mean? Well, if we kind of go back a ways, when we had, say, 4/12, well, we could have reduced that to 2/6, but we could reduce that to 1/3. And now we can't reduce that anymore because what we did is we combined these into the 2, we combined those into the 1, and that's the lowest we can reduce it. So lowest terms mean the fraction that we can't reduce anymore. Okay, so reading this out, a fraction is reduced to lowest terms if the greatest common divisor of both the numerator and the denominator is 1. So if we can't reduce it any larger, and if we think about that, we had that 1/3. The only divisors of 1 is 1, only divisors of 3 is 3, and we can't reduce that. So that is as low as we can go. Now, to get there, we need to divide both the numerator and the denominator by the greatest common divisor, and then it should be in lowest terms. Now, we can also think about canceling out the factors that's the largest in each part, both the numerator and denominator. So, either we're going to divide by the GCD, or we're canceling out the factor that's the largest in each part. They both mean the same thing. We're just different wording, but it's going to be how it works. It's going to work the same way. And so let's look at our first example here, 34 divided by 30. Well, first off, probably the thing to do would be find all of our common divisors. So, again, that's going to take some time. So 34, well, 1 and 34. Let's just write them as we go. Now 2 will go in here. Well, yeah, 2 will go in here. And what will be that? That'll be 17. 3, well, that won't work. 4 won't work. 5 won't work. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now we're back to 17. So really, it's just those 4. So we can erase that second last comma there. We don't have any more. So 1 and 34, 2 and 17. Now, if we wrote it in order, it'd be 1, 2, 17, 34. But I decided we're just going to write them as we find them. So what about 30? Well, 1 and 30. Well, 2 will go into 30 even. 2 and 15. 3 will go in here. 3 and 10. 4, that won't go in. How about 5? Oh, yeah, 5 and 6 will go in. And then 7, no. 8, no. 9, no. 10. Well, now we're back to here. So now we have all of the divisors of 30 here, all of the divisors of 34 here. And what's the greatest one? Well, we have 1s, we have 2s, and that looks to be GCD is 2. And so if we think about that, if we take 34 divided by 2 and we take 30 divided by 2, that should give us our reduced fraction. So 34 divided by 2, well, that's going to give us 17. 30 divided by 2, well, that's going to give us 15. Now, can we reduce that anymore? We shouldn't be able to because we've already found the greatest common divisor. So that's the biggest thing that's in common to both of them. And if we think about that 17, that's kind of a prime number. 15 is 3 and 5, and that won't go in there. And so that fraction then is reduced to lowest terms. And all we did was we found that GCD and divided numerator and denominator by the same thing. Okay. All right, so let's do some more. So here we have 90 and we have 39. All right, 90. Well, that's going to be 1 and 90. And then 2 and 45. And then 3 will go in here, and that's going to be 30. And 4, no, 5 will work. 5 will go in here. Now 5 into 90, I don't know that off the top of my head, so I'll do that one. That's 5, subtract, that's 4, bring down 0. So that's going to be 5 and 18. All right, so will 6 go in there? I think it will, so let's do that. 6 goes in here once, that's 6, subtract 3, 0, and 6 times 5, so 6 and 15 work. 7, no, 8, no, 9 will, 9 and 10. And then we're basically at the end, because then we're going to go and we'll hit the 15 and 18 and 30 and then 45 and 90. So those should be all the factors. Now, what about 1 and 39? Well, 1 and 39 are going to be, so 39 is what we're working with now. 2, that won't go in there, but 3 will. 3 will go in here 13 times, okay? And then 4 won't, 5 won't, 6 won't, 7, 8, 9, 10, 11, 12. Then we're back to 13. So that looks like that's the only factors, okay? So now if we look here, 1 is common, 3 is common, not 13 and not 39. So it looks like here the biggest one is 3. So what we're going to do is we're going to divide both the numerator and the denominator by 3. We divide that by 3, we get 30. We divide that by 3, we get 13. And that is our reduced fraction. Okay. All right, so what about 66 and 10? Okay, well, we're going to do the same thing. So maybe pause here and try to figure out what you get for your divisors, and then your greatest common divisor, and how you reduce it, and see if you get the same thing. And I'll go ahead and work it here after you unpause it. You can see if you get the same thing. All right, so we have 1 and 66, 2 and 33, 3 and 22, 4 doesn't work, 5 doesn't work, 6 does with 11, 7, no, 8, no, 9, no, 10, no. We're back to 11, so that should be all of our factors. Now 10 is 1 and 10, 2 and 5, and that's all we have. And so our common divisors are 1 and 2, 2 being the greatest common divisor. So we divide by 2, divide by 2. Well, 66 divided by 2 was 33, and 10 divided by 2 was 5. And so 33 over 5 should have been what you got, okay? All right, so here we have a huge one. And now this one is kind of meant to be one that says, hey, there's got to be an easier way to do this, okay? And so 168 and 180. So we have 1 and 168. 2 will go in there, and 2 goes in there, and that's going to be an 8 and a 4, so 84. Now, will 3 go in there? I don't know. 168 divided by 3, so that's 5, that's 15. Subtract, that's 1, that's 18, that's a 6. So yes, 3 and 56 work. All right, what about 4? Yes, it should, because 4 goes into 16, 4, and then in here 2, so 4 and 42. 5 should not work. 6, that probably works because it's divisible by that, so 6 goes into 168, so that's going to be 2, that's 12, subtract, that's 48, so 6 and 28. 7 might work. So that's going to be 2, that's 14, 28, and 4 times. So 7 and 24. Okay. What about 8? 2 and 4, so it should. So 8 goes in here. 168, that's 2 and 1, so 8 and 21. And I'm thinking I should erase the 180 here because it's going to have to go down lower. And so now let's go down to the next line. How about 9? 9, no. 10, no. 11, no. 12 might work because we have a 3 and a 4. So 12 into 168, 1, 12, 48, 4. So 12 and 14. And then 13 doesn't work, and so we're basically done. So we can stop now. All right, so as we can see, these larger numbers have a lot of them. So is this the most economical way to spend our time going through all the factors to find the greatest common factor? Not really. And so what we'll do is we'll finish this problem and then we'll move on to a new one, a new way to do this. And so 180. So 1 and 180, 2 and 90, 3 and 60, 4 and I think 4 will work. 4 into 180, 4 times 4 is 16, then 20, so 4 and 45. 5 should work because it's divisible by a 5, 180, so that's a 3, that's 15, 3, 0, that's a 6, so 5 and 36. 7, oh wait, 5 after 5 is 6, so 6 works, that's going to be a 30. And then after 6 is 7, no. 8 goes in, no. 9, yeah, 9 will work, that's going to be 20. 10 should work because that's going to be 10, oops, 10 and 18, not divide by. 11, no. 12, I think will, because we have 3 and 4, so 12 we'll say it is, and then we'll divide it. And it's going to go in ones, that's 12, that's 60, that's going to be a 5, so 12 and 15. And let's see, how about 16, no. 17, no. 18 we already have. And so that's our exhausted list we had to go through. All right, so now find the greatest common divisor. Well, we go 1, 2, 3, 4, and then we go up to 6, and then we have what after that? 12 is in there, and then 15, no. So let's say we have 12 so far. 15, no. Then 18, no. 20, no. 30, 30. Okay, so it looks like 12 appears to be the largest one. So that's going to be our GCD. So we're going to divide by 12 and divide by 12. So 12 up on top is going to be 14 because we did the pairs. And here it's going to be 15. So our reduction from 168 over 180 is 14 over 15. Okay. So that's, the long way about doing this. And so what we're going to do now is come up with a new way to do this to make it a lot simpler. And I'll pause there before we start that new way.